So let's understand with some step that you have to remember, and by same using that step you have to solve the example. So let us consider second order linear homogeneous differential equation. This P0 of x y double dash plus P1 of x y dash plus P2 of x y is equal to 0. Say equation number 1. Okay, this kind of equation is given. Now here you should not divide by this. You have to just check that x is equal to x0, and in our case we have always this value is 0, okay, in this syllabus. So if x is equal to this x0 is an ordinary point of equation 1, then the trial solution is y is equal to sigma n is equal to 0 to infinity a n x minus x0 whole raised to n. If this x0 is 0, then this become y is equal to sigma n is equal to 0 to infinity a n x raised to n. Okay, that we have to compulsory remember. Okay, I am just explaining this method. That's why I am using this x is equal to x0. Okay. Now we will differentiate this y with respect to x two times because we need this y dash and y double dash, and this is our trial solution. We are just taking this solution as a trial. Okay, and we have this y here. So we will find y dash, that means sigma as it is, an as it is, and one power forward and power minus. Okay, but if we put n is equal to 0 here, so this term becomes 0. So we'll start sigma n is equal to 1. So you have to remember this thing, that in y dash we will start with n is equal to 1. In y double dash we'll start with n is equal to 2 because we have one more derivative, that n minus 2 forward and 1 power minus n minus 2. So if you put n is equal to 1 also, this becomes 0. So for n is equal to 0 and n is equal to 1, this term becomes 0. So we'll start with n is equal to 2. That this is the fixed that you have to use it in each and every example. But as I told, we have x0 is 0 compulsory, so this becomes 0, 0 and 0. So we have x raised to n, x raised to n minus 1 and x raised to n minus 2 in example. So this is our first step. That first step, write down the trial solution. Second step, we have to just put this value y dash and y double dash in equation number 1. Okay, so substitute the value of y dash and y double dash in equation 1. Then second, this is our second step. Okay, this is our second step. We have to just remember 5 to 6 steps. So first step, write down the trial solution. Second step, substitute all this value in equation number 1. Third step, we have to just simplify. Okay, we have to just simplify. And fourth step, make power of x equal, because we have x0 is 0. So make power of x equal. Okay, this is our fourth step. Third step is simplification after substitute this value. Okay, and fifth step is make limit of sigma equal. Make limit of sigma equal. Right now you just remember this step. Then how to apply we will learn in example. Okay, so first step is trial solution. Second step is substitute all these value y dash, y double dash in equation number 1. Third step is simplification. And fourth step is make power of x equal. Make power of x equal. Fifth step is make limit of sigma equal. Then after making limit of sigma equal, collect the like power of x, because we have this is equal to 0. So collect the like power of x. Then equating to 0 the coefficient of various power of x, because we have this 0. And find the value of a2, a3, a4 and so on in terms of a0 and a1. In some example we have only in terms of a0. Now after getting all this value, just substitute all this value in equation number 2, that means in trial solution, and we will get the final series solution of equation number 1. Okay, this is the step, okay, that you have to remember. Okay, again, first step is trial solution, second step substitute in equation number 1, third step is simplify, fourth step is make power of x equal, fifth step is make limit of sigma equal, sixth step is collect the like power of x, and seventh step is equating to 0 the various power of coefficient of x, or coefficient of various power of x. Okay, and then just simplification 2-3 step. These are our step of example. Okay, that you have to remember. Now We will understand this with one example so you can understand better. So we have example: solve the Lysander equation x minus 1 minus x whole 1 minus x square y double dash minus 2x y dash plus n into n plus 1 y is equal to 0 for n is equal to 0 by power series method. Okay, whenever it is given that by power series method or series find series solution, in that case you have to use this method, this chapter's method. Okay, otherwise it is asked solve only, not power series. It's not asked power series, then you have to use that HOD, higher order differential equation, that chapter. Okay, but here it is mentioned that power series method or in series solution. Okay, or near ordinary point. So now, as I told, we have to compulsory check x is equal to 0 is ordinary point or singular point. That is our first task. Okay, so for that, I am just giving you a shortcut that you have to check only that the coefficient of y double dash becomes 0 at this point at x is equal to 0, then x is equal to 0 is singular point. If coefficient of y double dash becomes 0 and x is equal to 0, then this point is singular point, and the coefficient of y double dash is not equal to 0. Coefficient of y double dash is not equal to 0 for x is equal to 0, then x equal to 0 is an ordinary point. So we have to just check that coefficient of y double dash should not be 0. Okay, for x is equal to 0, ordinary point. So here, if you put x is equal to 0, 1 minus 0 become 1, that is non-zero. So here, x is equal to 0 is an ordinary point. This is shortcut method. Okay, so I'm just writing down this equation, and for this we have to find the series solution for n is equal to 0. So we will put 0. So we have this term 0. So remaining term is 1 minus x square into y double dash minus 2x y dash is equal to 0. This is our equation number 1. Now, as I told, it is clearly that x is equal to 0 is an ordinary point because coefficient of y double dash is non-zero by putting this value, by putting this x is equal to 0. Okay, and we have to compulsory use x is equal to 0 only. Ready? Now, as I told, we have to follow that particular 7 or 8 steps. Okay, so first step is trial solution. So we'll write down the trial solution same to same, no change in the trial solution in each and every example. So in each and every example of ordinary point near x is equal to 0, you have to just write down this first step as it is. Okay, because we have x is equal to 0, x0 is 0, so x raised to n, x raised to n minus 1, x raised to n minus 2. And sigma running from n is equal to 0, n is equal to 1, n is equal to 2, and we have derivative of this term is this, and derivative of this is we have this. Okay, so we have to write down trial solution. Now we'll substitute the value of y dash and y double dash in equation number 1 here and here. Okay, so 1 minus x square as it is, value of y double dash is this sigma, this entire value. Now minus 2x as it is, and value of y dash is this entire value. Okay, and is equal to 0 as it is. So we will put this value. So we have 1 minus x square as it is. This is the value of y double dash minus 2x as it is. This is the value of y dash. To understand better this example, this is simple example, so easy, but for that you have to use note and pen, and with me you have to just write down this value by pausing the video. Okay, so you will understand better. So this is our second step, substitute. Okay, now we have third step, as I told, simplification. What is the meaning of simplification? That you have to multiply this 1 with this entire sigma. So 1 into sigma is as it is, and minus x square into this sigma. So x square multiply with this x square, x raised to n minus 2. And we know that if base is same, the addition of power, that means n minus 2 plus 2. 2 to cancel, so we have x raised to n. Similarly, we will multiply this with this sigma. So 2 goes with the constant and x goes with the x. So we have x raised to n minus 1 and plus 1 because here x raised to 1. So 1 cancel and we have x raised to n. Okay. So we have this step. 1 multiply with this is this, and x square multiply with this, as I told, we have x raised to n. Okay, and sigma n is equal to 2, n is equal to 2 as it is. Now we will multiply this 2x inside this sigma. So we have minus 2 here with an, and x goes with this x, so x raised to n. Okay, so this is our third step, simplification. Okay, this is our third step, simplification. I'm just copying all this. So this is our third step. So first step is trial solution. Second step is substitute. Third step is simplification. Now fourth step, as I told, make power of x equal. So here you can see here x raised to n minus 2 in first term. In second term we have x raised to n, and in third term we have x raised to n. So these are same. So now we will try to make this power n minus 2 into n. So we want to make n minus 2 to n. Okay, so what we will put here instead of n? So we can cancel these two. So we can put n plus 2. So 2 will be cancelled out. So we have n. So we will replace n by n plus 2 in first term only, not in second and third, because we have second and third term has access to n as it is. So you can make any of the power, but here we have access to n is as it is. Well, we have two term with access to n, so we'll change only first term. If we have only one term access to n, then we can change, or we can change these two term in access to n minus 2 also. So which power you want, that is up to you, but I'm just making easy. For that I'm just changing in first step only. So replace n by n plus 2 in first term only. So this n become n plus 2 is equal to 2 cancel. So n starting from 0. This n become n plus 2. This become n plus 2. This become n plus 2 minus 1. That means n plus 1. And this become n plus 2 to cancel. So x raised to n. So we have this step. N is equal to 0. This become 0 because of n plus 2. This an become a n plus 2, this n become n plus 2, and this n plus minus 1 become n plus 1, and this x raised to n minus 2 become x raised to n. This step as it is, and this step is also as it is. Okay, so this is our fourth step, make power of x equal. So now you can see we have x raised to n, x raised to n, x raised to n in all these three term. Okay, now fifth term is make limit of sigma equal. Make limit of sigma equal. Here sigma starting from 0, here sigma starting from 2, and here sigma starting from 1. So we will make equal to sigma, limit of sigma equal, we will go with the maximum number. So we have maximum n is equal to 2. So we will put n is equal to 0 and 1 in this term, and then sigma we can start from n is equal to 2. So we will put n is equal to 0 first time, then n plus sigma, that means plus, we'll put n is equal to 1, and plus we'll start with n is equal to 2. So we have this. If we put n is equal to 0, so a2, this 2, this 1, you can see, and x is to 0 is 1, so no need to write down. Plus if we put n is equal to 1, so 3, 3, 2, and x is to 1, you can see, and we will start this entire term with n is equal to 2, you can see. Okay, so here n is equal to 2 is maximum, so we will try to make each and every term with n is equal to 2. Now this term is as it is because we have n is equal to 2, so as it is, and now this is n is equal to 1, so we will put n is equal to 1, so we can start from n is equal to 2. So put n is equal to 1, so 2 a1 1 x is to 1, 2 a1 aa gaya, that means got minus as it is. Now minus, we will start this with n is equal to 2, same to same term, but with start n is equal to 2 because we already put n is equal to 1. Okay, so this is our, you can see, now you can observe that all the limit of sigma equal. Okay, so this is our fifth step. So first step was trial solution, second substitute in equation number 1, third simplify, that means expand this bracket with the sigma. Okay, fourth step, make power of x equal by replacing some term. Okay, fifth step is make limit of sigma equal. Make limit of sigma equal. So for that we have to put the value of n. Okay, and we will reach up to maximum n, which is already in this step. Okay, so this is our fifth step where we made already limit of sigma equal. Now collect the like power. So we have, this is the constant term only, and we have this two term, this with x, and this also is with x is to 1. So we will collect these two terms together, and remaining all the terms, number 1 this term we have sigma and x is to n same, this term similar way sigma and x is to n is same, similar way we have sigma and x is to n is same. Okay, so we'll take these three terms together. So by collect, that means we have six steps. By collect, constant term, term with x, and term with sigma and x is to an outside, and remaining three term here. Okay, so this is our sixth step. Collect the like power of x. Now seventh step is equating to zero the coefficient of various power of x. Just follow this step only, so it will make so easy for you. So now equating the coefficient of various power of x. So this is the coefficient of x raised to 0. So we'll equate this equal to 0. This is the coefficient of x raised to 1. So we will take this equal to 0. And this is the coefficient. This is the coefficient of x raised to n. So we take this equal to 0. So we have first 2a2 is equal to 0. So a2 is equal to 0. We get the one value. Similarly, we have 6a3 minus 2a1 is equal to 0. So if we will make this subject, we have to make the term subject which with greater value of a. That means a3 is greater than a1. Do not consider this 6 and 2. Do not consider the coefficient. Just see this a3 is greater than a1. So we will make a3 subject. Okay. So 6a3 is equal to 2a1. So a3 is equal to a1 by 3. Okay, and third step is this. We'll equating this equal to 0. A n plus 2 into n plus 2 n plus 1 minus a n minus 1 and minus 2 a n. So this equal to 0. Now here also we will make larger a sub coefficient. Okay, suffix. So we have a n plus 2 is greater than an. So we'll make this subject. So we'll take this 2 on the right hand side. Okay, now we'll take an common from this two term. So we have an outside and n minus 1 plus 2n. Now we'll expand this. So n square minus n plus 2n. So n square plus n we have term. So now by factorizing this, we have n into n plus 1. By cancel out this n plus 1, and we'll take this on the right hand side. So we have n plus 2 is equal to this, and this is our recurrence relation. Okay, so this step gives us recurrence relation between this n plus 2 and an, and we will start the value of n from where we stop the sigma. Last step, collecting. Okay, in collecting we have sigma n is equal to 2, so we'll start with 2. If we have n is equal to 0, then we'll start with 0. Whatever the last step, collecting step. Okay, whatever this sigma starting from n is equal to in collecting step, that we will use here, and this is called our recurrence relation. Now we will put the value of n is equal to 2, n is equal to 3, n is equal to 4 in this recurrence relation. So we will get, so we have this recurrence relation and we have n. So first for n is equal to 2, this 2 plus 2 becomes 4. Here 2, a2 and 2 plus is 4. Now we know that we already find that value of a2 is 0. So this become entire 0. So we have a4 is equal to 0. Now we will put n is equal to 3. So 3 plus 2 is 5. This is 3. This is a3 and 3 plus 2 is 5. Now what is the value of a3? So we know that a3 value is a1 by 3. Already we find. So by cancel out these 3, we have a1 by 5. Value of a5. Similarly, we put n is equal to 4. So we will get a4 here 6. 4 a4 by 6, and a4 is 0. a4 is 0. So this term is also 0. Now we will put n is equal to 5. So 5 plus 2 is 7. This is 5 a5. 5 plus 2 is 7. Now we have value of a5 is this a1 by 5. So we will put here. By cancel out this 5, we have a1 by 7, and so on. So we will put only 3 or 4 value, or if we have complication, then we will put only 2 values. No need to put each and every values. Okay, because we have n running from 2, 3, 4 up to infinite. That's why. So we'll write down so on. Now we will put this value of a2 was 0, a3 was a1 by 3, a4, a5, a6, a7, all these value in equation number 2. Okay, equation number 2, that means in trial solution. This is our trial solution. We'll expand this by putting the value of n is equal to 0, 1, 2, 3, this. And now we'll put the value. So we have a0 as it is, a1x as it is. Now we know the value of a2 is 0, a3 is a1 by 3, a4 is 0, a5 is a1 by 5, A6 is 0, A7 is A1 by 7, and so on. Now we will take common from this term. So A1, 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 A1 common, and A0 is only single. So we'll take A1 common. So we have this is our power series solution. You can see we have the solution in series form, power series, x is to 1, 3, 5, 7. And this is our final general solution, and where this A0 and A1 are arbitrary constant. Okay, so similar way we have this example. You have to just try with that same step. First step, trial solution. Second, substitute in equation number 1 the value of y, y dash and y double dash, whichever we required. Third is simplification. Fourth, make power of x equal. Fifth, make limit of sigma equal. 6, collect same power. 7th, equating to 0 the various coefficient of various power of x, and then we will get the recurrence relation, and in that recurrence relation we will put the value of n. N is equal to starting from where we stop in collecting step. Okay, so we will start with that n, and we will get the value of a2, a3, a4, or a1, a2, a3, a4 in terms of a0 and a1, and we will put all this value in trial solution, and we will get the final power series solution. Okay, this is the your entire example. So please try to solve this 4 example. This will help you in next lecture, because in next lecture I am not explaining each and every step, because in next method also you have to follow this step only, but with some little bit changes. Okay, but steps will be same. That's why I'm just giving this method in this solution near ordinary point. Okay, so thank you for watching this video. We will see you soon with next video. Thank